the video later. So today we're going all over assignment 1, how to set up the environment that you'll be working in, whether that's Mac, Linux, or Windows. And just as a quick show of hands, who's going to be using Windows this term? Most people, cool. Any Linux users? Any Mac users? Okay. So typically what I've done traditionally for this class is that I go over the environment setup and then I go over the assignment. What I'm going to do today is go over the assignment first and then the environment setup. Because if the environment setup part, so this is a new laptop, it's got Windows 11 instead of Windows 10, which I'm not as used to. And so if the environment setup is a complete disaster, if I do it at the end, then I can chop it off and just put the video that I did last year. And it'll be way better if it's a disaster, but we'll see. I don't think it'll be a disaster. So I'm going to go over the assignment first, and then I will go over how to set up the environment that you're working with. So let's just go over the whole README file. I like to go through. So every assignment comes with a marking scheme text file, which will tell you exactly how many marks each part is worth, and also a very detailed text file that explains exactly what to do in the assignment. And so I write the text file, believe it or not, for myself more than you, so I can remember the assignments and remember what I said to do. So we'll just go over all that now. So hopefully this thing is going to work. Okay, it's going down line by line. That's fine. So this triggers me. I got to move that off to the side. All right. So assignment 1, just keep a note for assignment 1 that you're required to submit main.cpp and no other files for this assignment. Submission will take place on D2L's assignment 1 Dropbox, and only one student from each group of 2, if you're choosing to work in a group of 2, should submit the assignment. If you're on the fence about getting a partner for the assignments, if you're not sure if you're going to do all the assignments alone or not, this assignment is about half to 2/3 of the work of assignment 2, and the amount of work in each assignment just goes up a little bit each time. So if assignment 1, if you choose to do that by yourself, and it's a little bit too much work, it doesn't get any better. You should be able to do, everyone here should be able to do assignment 1 by themselves, but assignment 1, there's a lot of setup, a lot of figuring out stuff, right? So you might spend like, I don't know, a fifth or a sixth of the time of this assignment just setting up the environment, right? And then you've got all the programming stuff to worry about. So for this assignment, you're only submitting main.cpp. For the other assignments, you're going to be zipping up the entire source directory and submitting the zip file. So there's just the difference between this assignment and the next. And working solutions are included with the assignment so that you can see what a correct solution looks like. These executables are located in the bin directory and are provided for you for Windows. So I am providing a Windows 10 and 11 64-bit executable that you can run to see what the solution looks like. So let's actually go over that now. I guess I'll just make this. I have seen every which way submitting this assignment. It's insane what people try and do. People copy it into Word docs and submit that. But luckily, D2L now has a feature where you can I can specify only .cpp files or only .zip files are allowed. But yeah, no project files, no anything, just exactly what I'm asking for, please. And since only one of you is going to be submitting, at the top of main.cpp, there will be all of your student information that's already filled in there for you with the zip file. And just put the other student's full name, username, and student number along at the top of main.cpp. And if you didn't get anything to work, such as text centering or whatever, just explain what you tried to do, and I'm very lenient usually with partial marks if I see that you at least tried something. However, if you tried something that didn't compile, don't leave that in there. If you get 90% of the functionality working, but then your code doesn't compile and run, I'm not going to sit there and fix your assignment to the point where it runs and only gives partial credit, right? Like, make sure what you submit actually compiles and runs. Don't leave uncompilable stuff in there. So let's have a look at the assignment on the desktop. Okay, so this, I think, is as big as I can make this. View. I don't know. It's the first time I ever used Windows 11, like 2 days ago. All right, so I know that this is small here, but on the video you'll be able to see it, right? So there's a few files here. One is the marking file, that's a text file. One is the README file, that's what we're currently looking at. One is the makefile. I'll go over that in the setup process. Then there are 3 folders. One is the bin folder, one is the source folder, and one is the Visual Studio folder. The Visual Studio folder contains the Visual Studio project and solution files. So in here, you will see there is this SFML game.sln. So when you go to open your project, that's what you're opening, the solution file. So a solution file can contain 1 or more project files. And so I already have all of that set up for you. When you compile your stuff with Visual Studio, you'll see that there are some temporary directories that are made in here. Those contain all the object files that we were talking about in the C++ lectures. So all the intermediate temporary files, they're all in this x64 folder that goes into that folder. The source folder, for most assignments, it will contain a bunch of header and CPP files. But for this assignment, it's just the main file. And it also includes IMGUI. That is a folder that contains all of the source code for the IMGUI library, which we will be using for the user interface stuff for our assignments. So I've included that for you here just as a, you don't have to set up that library, right? It's here for you. So the only library that you'll have to set up is the SFML library, which we'll get into later. And then the bin folder is going to contain some things. One is it contains the configuration file, and this configuration file, I'll go over it in a bit. It contains a fonts directory, so that will contain the font files that we'll be using to draw text to the screen in SFML. And it will also contain 2 executables that I've packaged with you. One is called A1 solution, so that's the executable that will show you how the solution should look once you finish. And one is A1 student, which is just to give you a reference point to what it looked like when it started. So the code that I ship to you as the default code, that is A1 student. So essentially what this assignment is, I'll just show you first and then I'll read through it. There's a config file, and this config file specifies the window size, some font properties, and a number of shape properties, like circles, rectangles, with some strings, some numbers here, etc. Those are denoting colors, speeds, and locations. And by the end of the assignment, what you will have, and this is going to be small as well, Windows scaling doesn't affect SFML things, but this is what you'll have. You'll read from that config file, and you'll draw all the shapes with the various speeds, and you will you'll make them bounce off the sides of the walls. Okay? And also, and this is literally impossible to see because of Windows and resolutions, over here you have a user interface in which you will be able to select one of these shapes. So for example, I'm selecting I got the green shape selected now, and I can do things like make that shape bigger, okay? Or I can change its velocity to make it go faster. Or I can change its color in here. So the blue one, or the green one, is now some weird shade of blue or red or whatever. And so this is how your assignment will look when it's finished. You're going to take the text in the text file, center it perfectly, and you're going to write this little user interface here. So this is the Welcome to C++, SFML, and IMGUI. It's not a game. Well, I guess it is kind of a game. But this is what we'll be using as the basis for our programming for the rest of the semester. And all of the assignments, and when you get the assignment, it looks like this. It's just some demo code where there's just a circle, it's moving, and I give you some demo code to just change the properties of this circle. Okay, and you can like click buttons and stuff like that to reset it. and you can set text, whatever. So that's what I give you, and you have to turn it into what I just showed. So there's going to be some things that you have to do there, and I'll show you those things. Okay, so all of the other assignments for the entire term will, when you look at the root directory, so this is the root directory of the assignment, you will see the exact same thing. You'll see bin, source, Visual Studio, then the marking file, the makefile, and the README file. So every other assignment will be exactly the same. And after you have set up the assignment for assignment 1, all of your other assignments for the rest of the term, you'll just be able to download, go into Visual Studio, and double-click if you're on Windows. Otherwise, you open a terminal and you type make, and it should just work. So that's how it is. Like, all the other assignments will be the exact same format, and yeah, it shouldn't be too bad. So there's no setup after the first assignment, ideally. So let's go back to the README file. Okay, so that was how to submit it and stuff. So here is the program specification. So in this assignment, you will be writing a C++, an SFML, and IMGUI program, which will read descriptions of shapes from a configuration file and then draw, typo, those shapes to the screen. Each shape will have a name, position, speed, color, as well as properties unique to that shape. For example, a rectangle will have a width and a height, and a circle will have a radius. So rectangles and circles are a little bit different in their properties. For this assignment, the position of a shape refers to its SFML default of the upper left corner of that shape. So just a quick note on how the XY coordinate space works. When I taught this online, I had a really nice blackboard set up, but I forgot to set that up here. But essentially, if you've done any math, then 0, 0 is in the bottom left-hand corner. But in most graphics libraries, 0, 0 is in the top left-hand corner. Okay? So X increases going to the right, and Y increases going down. And on the video, you don't see that laser pointer, but just know that, so X increases going to the right, and Y increases going down. Okay. So the position of a shape by default, and in this assignment, is that if you take a circle, for example, where it gets drawn is at its position, that will be the upper left corner of the bounding box of that circle. If it's a rectangle, then the position is just the top left corner of the rectangle. In future assignments, we will change that to be the middle, and we'll talk about that when we get to it and why we do that, but by default, it's the top left corner. It goes on. You are also required to make these shapes bounce off the sides of the window which contains them. This means that if the shape's left side hits the left of the window, its X speed reverses. So to reverse the speed, all you have to do is multiply the X component of its velocity by -1. That's just as how you reverse the speed. If the top of the shape hits the top of the window, its Y speed reverses. So similarly, you would take the Y component of its velocity and just multiply it by -1. Similarly, if it hits the right side or the bottom of the window. So if it hits the right, multiply the X speed by -1. If it hits the bottom, multiply Y speed by -1. You can assume that all shapes will always be configured to start entirely within the window, and you don't have to worry about what happens if they start outside the window. Okay, so there's no like weird edge cases where a shape could start halfway through. I'm going to make sure that the config file, it's nice to you. Each shape's name should be drawn on the exact center of the shape in the given font size and color specified in the file. And just as a quick note, that may actually be one of the trickier parts of the assignment. It's really easy to get the text almost centered. It's kind of difficult to get it perfectly centered. And by perfectly centered, I mean that the middle of the text's rectangle is at the center of the circle. So you're not drawing it with the bottom of the text in the center of the circle. It's the middle of the text in the center of the circle. Alrighty. You are also required to implement an IMGUI user interface which is able to do the following things. 1. list all of the shapes and select any one of them to edit their properties. There's a number of different ways to do that. And in the next lecture is kind of a quote-unquote free lecture where I'm just going to come up here and like do some programming that is related to the assignment. So I'll go over like an SFML tutorial, I'll go over IMGUI tutorial, show you how to inspect the IMGUI demo file, etc. So this lecture is all about explaining stuff for the assignment and the setup. And in the next one, you can bring in your laptops if you want and work, and I can even answer questions or give you help. So the next lecture is all about helping with that. So there's a number of different ways that you could accomplish this first one. There are combo boxes or drop-down lists. There are lists of things. There's all sorts of different ways. Whichever way you give me of selecting the object, that's fine with me as long as I can. You're going to have to be able to toggle whether or not the selected shape is going to be drawn. Change the scale of the shape. So the scale of a shape, it changes, like it multiplies the size by that much. Okay? And I'll show that in the next lecture. Change the x and y velocity of the shape. And so this is the range of the selector. So every selector where you can select something, it's got a current value, a min value, and a max value. And so by default, the scale is going to be 1 because it's normal size. So that selector is going to be between 0 and 4, and the x and y velocity is going to be between -8 and 8. You're going to be able to change the color of the shape as well as change the name of the shape. So all that is there in the solution if you look at that. And just a quick note on the UI. If you're doing things like really quickly changing the size of something, it could bug out the program where like the shape goes off the side and doesn't properly get bounds detected. That's okay. I'm going to make sure when the TA tests this that like we're going to make sure that when we resize it or scale it that it'll still be within the bounds of the rectangle. So you don't need to worry about that. So that's what that says. But the important part is that the newly scaled shape should properly bounce with its new size, not just the original size that it was given. So a sample configuration file is given to you in config.txt. However, marking will be done with an unseen configuration file in order to test it more completely. Be sure to add and remove your own shapes to this file to test if they all work correctly. So for example, in the config file that's been given to you, there will always be a window line, a font line, and then there could be none of these. There could be 100 of these. There could be all circles, there could be all rectangles, there could be some mix of them, and they can come in any order. Okay? So you can't just hard code reading 6 shapes from the file. You've got to actually dynamically read this file. And if you have not watched the live coding section of the C++ lecture, the first one, I basically do this for you. So what I do is I give an example where I actually read student data from a text file and put them into objects. You'll be doing the exact same thing. There are just more properties here than in that example. Okay? So make sure that you do that correctly. And so what I meant by that note there is, try it without any of these things. Try it with like more of these things. Put in some new ones, delete some, and see if your code still works. Each line of the configuration file specifies one of the config settings of the assignment program, with the first string in each line being the type of setting that the rest of the line is specified. Lines in the config file can be one of the following types, and the lines can appear in any order in the file. So, window WH. This line declares that the SFML window must be constructed with width W and height H, each of which will be integers. So if we go over to the config file here, you can see that I have window 1280 by 720. So that's a 720p configuration. Feel free, if you're not submitting the config file to me, so you can change this to whatever you want that works for you and your screen size. Okay. The next line is the font line. So it's font and then a bunch of parameters. This line specifies the font which is to be used to draw the text for the program. The format of the line is as follows. This F, so it says font first, so you know what type of setting this is. Then there's F, that is the font file. This is a string, it will have no spaces, and it specifies the font file that's to be loaded. Then there's S, that is an integer, and that is the font size, so size 18 font or whatever. And then the next, there's 3 integers, R, G, and B, and those are 3 ints specifying the color of the text to be drawn. So in SFML, and I'll go over this in more detail in the next lecture, but it is going to be, you're going to be specifying RGB colors by values that are integers between 0 and 255. Okay? And again, I'll have all of that for you in the next lecture. Then there is a rectangle followed by a number of properties. And so this defines a rectangle shape. So in SFML, there is a rectangle shape object so it says rectangle n is the name. So that is the string that you're going to be drawing in the middle of that shape. Then you have initial position, that is the x and the y. That is the starting position of that rectangle, the top left corner within the window. And those are specified by floats. Most of the time, we specify positions in the SFML world as floating points. Then we have our initial speed that starts with. And so it's an x speed and a y speed, also called a velocity. So technically, I should be saying initial velocity because it has 2 components. And this is sx and sy floats. Then we have the R, G, and B, which are the colors. And then we have the size, which is the width and the height. So if I go over to the text file and I look, for example, at this rectangle, it says rectangle R red. So that R red, that's the string that's going to be drawn inside that rectangle. Its initial position is at pixel location 200, 200. So that's 200 down and 200 over. Or sorry, 200 over in the x, 200 down in the y. Its initial speed is 4 in the x direction and 4 in the y direction. That means every frame that the game or that the window is open, it's going to be moving 4 pixels over and 4 pixels down. It has R, G, and B equal to 255 in red, 0 in green, 0 in blue. So that means it's red all the way, no green and no blue, which gives it the overall color of red. And then it has the size of 50 in the x direction and 25 in the y direction. So that's a relatively small but fast-moving shape. So if I run the assignment again and I look at that red one, it should be a smallish, fast-moving. Yeah, there we go. Right? Pretty small. 50 pixels is not a lot. There we go. So that's what that specifies. And then the other ones, you can see what those properties may be. Okie doke. Back to the README. And then the last thing is the circle, which is exactly the same as the rectangle, except at the end, instead of having a width and a height, it just has a radius. Okay? So that last R is the radius. And that's it. So all of it is the same except the radius. I always provide some assignment hints at the bottom here. And I will be going over these again in the next lecture as well. But in order to store an arbitrary number of shapes from the configuration file, you must store them in a container, right? You have to have some sort of container to dynamically store a variable number of shapes, okay? So I recommend a vector. You can use whatever ends up working. But you've got to be able to store all the circles and all the rectangles. What I would consider as a way of doing this is that you've got a bunch of shapes with properties, and they can be different types of shapes. What I would recommend is to create a custom class or a struct, call it, I don't know, shape, which stores all of the properties of that shape that are not stored within the SF shape class itself. And so in the next lecture, if you want to start the assignment before the next lecture, by all means, you can solve this by Thursday easily if you want to. But I will be doing a tutorial lecture that shows you all the properties of the shape class, all the properties of the rectangle class. And so the point here is that the shape class stores things like its current color, its current position, its current line thickness, its current radius, its current width and height, all those things. But it doesn't have a place to store a name or a velocity, etc. So you may want to create a custom class that stores all of those things that I have associated with that shape, and then store that custom class in your vector and then refer to that whenever you want. So for example, you could say, okay, I'm going to have a new class with all public variables, or a struct. It's going to store the actual shape object, whether it's a rectangle or a circle shape, or whether I'm storing the base class pointer to one of these things. And then I'm also going to store the name, the velocity, whether or not it should be drawn, all those different properties. Okay, so a shape will touch the side of the window if its bounding box makes contact with it. So the bounding box is the smallest rectangle that can contain a shape. Okay, and so each shape's bounding rectangle can be obtained via the shape.getLocalBounds function. And so this gives the local position of the rectangle, local meaning it's relative to the get position, local relative to the position, not the window. Or you could also use getGlobalBounds, which will also take into account any scale or translation that's been applied to the shape. So if you have a shape and you want to get at its bounding box, for example, you can use these functions that are built into SFML to do that. And again, when I get into the next lecture, I will be going over more of that in detail. Similarly, if you have an SF text element that will be drawn to the screen, its bounding rectangle can also be retrieved via the getLocalBounds function, and you'll need to do that in order to properly center the text within a shape. So text has a size, but when it's drawn to the screen, its pixel size is different than its font size. So you have to ask for its pixel size to figure out where the middle of it is to then properly center it within the shape. Please use C++ file reading, not C-style file reading. And so standard IF stream, input file stream, that's the same type of stream that we used in the live coding session. It makes it really, really easy. I would argue that reading this configuration file, the easiest possible language to use is C++. It's like the least amount of characters of code to read that in. It just does it for you, basically. Rather than C-style file reading. So if you've taken a C course and you're used to like a file pointer equals fread, none of that stuff, please. You will lose marks for using older C-style functions because we are using modern C++ in this course. Okay, so that is the assignment description. And if I go into Visual Studio, I'm going to see, if I can scroll this, what I have given you so far. So I'm kind of making this, so this is Visual Studio. Let me give you a brief tour of Visual Studio. Over here on the left, in a font size that you can barely see, are all of the project files. So the topmost thing in this hierarchy, that is the project file. I have just called it SFML game. And then inside that are all the files that are necessary to compile and run this project. So in here, there is a folder that contains all of the IM-GUI code. You will never have to open that folder. Just leave it there. Don't delete it. It has to be compiled with the program in order for it to work. But the thing that you are concerned with is the only file that you'll be editing for this assignment, which is the main.cpp file. So what is main.cpp? Well, it does everything for the assignment. So if we look here at main.cpp, I'll go through this in brief without providing any additional code examples. And then in the next lecture, I'll go into this in greater detail and change some things, provide some examples for you. So up here, we have included some C++ standard template library includes, such as IOStream, which you may need for writing to the console if you want to debug stuff. Memory is used for standard shared pointer, which we went over in the last lecture. Then we have fstream, which is file input and output, which you're going to need to read the files. This here, this line includes the SFML graphics library. So you can see here this is a .hpp file, which tells us just from the extension that that is a header file and implementation file all in one file. And so that lets us use the SFML library. And next are two includes that we need in order to use the IMGUI library. One is including IMGUI and all its functionality itself. And then there's a second one, which luckily someone was very nice and made an IMGUI library specifically for SFML. And so we are using the IMGUI-SFML library. It still has all the same functionality as IMGUI. It's just much easier to set up this way rather than using base IMGUI. So what do we have here in this file? Well, right as I've given it to you, I have put everything in a main function. So we just have int main and that's it. The entire demo skeleton code that I've given you is all within this main file. You are free to do whatever you want to implement assignment 1. The only thing you cannot do for assignment 1 is create additional files. Okay? So if you want to make a custom class, you're not going to be putting it in a header file. You're just going to be writing it above the main function. If you want to have other functions, like maybe you want to read the config file and return some object, you can create your own function. It just has to be declared above the main file, above the main function. But just for assignment 1, everything is going to live in main.cpp just to make myself and the TA's life a little bit easier. So up here we see our main, int chargstar argv. We're not going to have any arguments that we pass into this program. But so let's go over the sample code that I've given you. So this sample code here is going to create a new SFML window of a given size, width times height. The top left of the window is 0, 0, and the bottom right is width height in the x and y direction. You will have to read those from the config file before you create the window. Okay? So here I've just created two variables, window width and window height. And then the syntax for creating the SFML window couldn't be easier. One line of code, SF render window. That's the type of thing that we're going to be using, so it creates the window for you. The variable name is going to be called window, and then into its constructor, we pass a video mode object, which it just says, okay, what's the video mode that we're going to be using? By default here, if you specify a width and a height, it's going to be a window, and that's going to have the given size that you give it. And then this string here is going to be the title of the window, right? So that's going to say, hey, SFML works. It's going to be this width by this height. You can, in the future and in the project, you're going to have, there are parameters that you can pass in here to make this a full screen application, right? Full screen at whatever resolution your monitor can handle. But we're not doing that for this assignment. Yep?
Could you just explain what the SF ... means again?
So this is a namespace. SFML has a namespace, and that is called SF because they don't want you to type SFML ... each time. And S and F are kind of close together. So SF : means that anything after that lives within the SFML namespace. Okay, so go back and review the C++ lectures where I explained all of that. So anything that SF precedes is something in the SFML library, but that is a good question as a reminder. So this render window object lives in the SFML namespace. Down here, we can then call a bunch of functions on this window. One of them would be setting the frame limit. Okay, so this is done for us by this function, and it limits the frame rate of the window to whatever we pass in. So I'm going to leave this as 60 frames per second. I know most of you probably have high refresh rate gaming monitors at this point, but in order to make this run at the same speed for everybody, just leave this as 60 FPS. Now, setting a frame rate limit is interesting. It doesn't guarantee that it's going to run at 60 frames per second, because if you take 1 minute to update all your math in your game, it can't go faster than that, right? But what this does is it won't run faster than 60 frames per second. So if you don't put this in there, then the program is going to run as fast as your computer can handle it, and everyone's computer will have the shapes drawing at different speeds and stuff. This was actually kind of funny. I forgot to include this in last year's assignment and every other previous offering of the course. And so the values that I had in the config file for my computer were like, some people were like, the shapes aren't moving, what's wrong? And so I had forgot to set in a frame limit. So this is what we'll be using. All right, so this sets up the SFML window. And now what we have to do is it's a little bit annoying, but we have to set up IMGUI as well. So IMGUI has to know where it is drawing stuff. Okay, so this says IMGUI SFML init. That's pretty intuitive, right? So IMGUI, the SFML part, we're going to initialize IMGUI to take the window that we just created. So all the IMGUI stuff is going to be initialized, are going to be drawn within that window. And then IMGUI, in order to perform its tasks properly with its input handling, it has to know how much time has passed between frames. And so there's a thing inside SFML called a clock, and the delta clock just means how much time has passed between this frame and the last frame. So you don't really need to know this, but I like to explain it anyway. And so we just set up those variables. And then something that I did not do in the solution code, but something you can do, is that IMGUI lets you style it with different properties. This will let you scale the user interface to be a little bit bigger if it's too small on your screen. But I embarrassingly couldn't figure out how to scale the font size in IMGUI in a way that I was happy with, so I'll continue to investigate that, and when I figure it out, I'll tell you. But this will make all the actual user... so let me run this. So I'm going to click local... OK, so this runs it. You can see sort of how big these UI elements are. So let's scale that now. And so if I pass in a 3 here, ideally everything should be 3 times bigger. So there's a compilation output window down here that I've hidden just because I had to increase. Yeah, so you see how much bigger that stuff is now? So basically everything has been scaled up except the font size. But like when I ran this on a MacBook Air to test, that resolution is insane. It's just insanely high resolutions. And so you're probably, if you're running this on a Mac without any window scaling, you're going to probably have to change that, okay? Which is fine. Just change it back to 1 before you submit your assignment. All right. So that's what that does. Next, in order for IMGUI, actually, I'll get back to that line. I'm just setting up a color here. So a color in RGB space, IMGUI uses values instead of integers between 0 and 255, it uses floats from 0 to 1. So IMGUI, unfortunately, that's really the only annoying thing with IMGUI, is that it uses floats from 0 to 1 for its colors instead of ints from 0 to 255. Next, there's a circle on the screen, and I'm going to be setting up a bunch of parameters for that circle. So for example, the circle radius, the number of circle segments, I'll talk about that next time, the speed of the circle in the x direction and in the y direction, whether or not we're drawing the circle, and the text that's being drawn to the screen. So I'm going to create an SFML circle shape based on our parameters. And so this, unfortunately, is not, it's word wrapping. So this single line goes to the next one. That's just because I've increased the font size by a bunch here. So let's create a circle shape. SFML could not be easier to draw shapes. You just say SF circle shape, and then give it a variable name. And then you give it the radius and the number of segments. Okay? And that's it. You've created a circle shape. Then there's a bunch of different things you can do to that circle. So we can set its position. So 10.0f, that's just a floating point number of 10, 10. So if that was this window, this will start like right up here, right in the top left corner, 10 pixels to the right and 10 pixels down. All right, now let's draw some text. So the first thing we have to do is create a font object. And in order to have a font object, we need to load a font from a file. And so this says myfont.loadFromFile, and we give it a file name. Now, just keep in mind that the assignment structure that I've given you has these folders. So bin folder, source folder, Visual Studio folder. If you use the makefile Or if you compile from Visual Studio, it puts the resulting binary file in the binary or bin folder. Okay? So if you're British, it's not the bin as in it's garbage, it's a bin as in binary. So your executable that I just compiled is this SFML game.exe. It assumes it's going to be run from that directory. Because, as you can see by what we just did inside Visual Studio, it's trying to read fonts/tech.ttf. And so if this is run from anywhere but the bin directory, it won't be able to see this fonts directory /tech.ttf. Tech is just the name of the font. I chose it because it was the smallest font that I could find to include with the assignments. So just like Arial, this is just Tech. All right, so you have to run this. So I can double click it here to run it, right? That'll run it fine. Or I can run it from Visual Studio because I have set up a setting in Visual Studio that runs it from the bin directory. Also, if you're in Linux, which I'll show a little bit later, you have to change directory to the bin directory and then run it from within the bin directory. But if you use the makefile in a proper way, you don't have to do that. Just make sure that you run it somehow from the bin directory. So what this does, this myfont.load from file, that will try to load the font. If it's successful or unsuccessful for any reason, this load from file function returns a Boolean. It returns true if it loaded the font. It returns false if it couldn't load the font. So if not myfont.load from file means try and load the file, and if it was not successful, print an error. So we've all seen standard cout. There's another thing called standard cerror, and this will print out to the error console, which is the same terminal, but there's minor differences. I'll talk about that a bit later. But you'll print out an error and just exit the program with something other than 0, right? So it'll exit with -1. All right, so that's what that does. It loads the font file. Next, we have to set up a text object, and that text object takes in its constructor a string, which is the text you want to draw to the screen. It takes in a font object, which is my font, and it takes in a font size, and that's the size that will be drawn to the screen. Now what we want to do, just for the demo purposes, is I've shown you how to position the font file. So if I run this again, you can see here sample text is being drawn with the very bottom of the text at the very bottom of the window. And so in order to do that, I have said text.setPosition, so it's at 0 in the X, so it's the very left-hand side of the screen. And then it's the height of the window minus the height of the text. Right? So if I take the height of the text, subtract that from the height of the window, I'll now be sitting on the bottom of the window. So you're going to have to do something like this, except instead of using the window height, you're going to have to be using the shape properties to get its size to position it properly in the middle. Okay. Next, this is for IMGUI, and I know I haven't shown the IMGUI code yet, but in order for IMGUI to allow you to enter text, it has to be given an array of characters to put that text into. So this sample text, that's what's going to be drawn to the screen, and I'll show you this in a little bit. So again, the last part of this demo here is that here, which is impossible to see for you, but if I type in hello 4300 into that box and click set text, then the text that is drawn down there is now changed. And so what you are editing right here when you type in that text box, that is editing this array value right here. Okay, so that's what that's doing. Now, the bulk of the code for any game is in the main loop of the program. And I just realized, is it really 11:15? Oh my God. Okay, so I got a half hour left. I'm gonna kind of breeze through this, and I'll go over it in more detail in the next lecture, but I got to get through the setup for you. So there's essentially, it says, keep looping while the window is open. Handle some events right here. I'm going to let you look at that for now, and I'll get into that. I'll do a bunch of different examples of that in the coding lecture. So there's keyboard events, there are mouse events, there's all sorts of different events that we have. Then we have to tell IMGUI to update the window. Then that entire user interface that does all of that is this. That's the benefit of immediate mode GUI. Okay, and I'm going to get into what all of this does in the next lecture, but like, hey, I want a checkbox. And the cool thing about immediate mode GUIs is that what you do is you set up a UI element and you pass in a pointer to data. And then the UI element directly modifies whatever lives at that pointer. So for example, this slider float of radius, I pass in the pointer to the radius of the circle, and when I'm moving that slider in the UI element, in the UI, it's directly modifying the floating point number that lives at that. And so it's like, that's why it's called immediate mode GUI. There's no callback functions that like you have to take the result of a click and then do something with it. It directly and immediately modifies addresses in memory. Okay, so that's the entire UI. And buttons, it just says, if button with a label, do something. It's the simplest possible UI. It's insane how powerful this is. And then I set up the properties of the circle. I set the position of the circle to be updated with the speed, right? Because every frame that this is being drawn, I take the previous position and I add the speed to it. Then what I do is I clear the window so that it is now black. If I did not clear the window, let's see what happens. So let's comment out that and rerun it. It just keeps drawing to it, right? So you got to clear the window. Then I say, if I'm supposed to draw the circle, window.drawCircle. How much easier could it be to draw a shape than window.drawCircle? If I'm supposed to draw the text, window.drawText. Then we have to tell IMGUI to render itself to the window, and then window.display, it swaps the buffer. So I'll get into what swapping buffers mean, but this essentially says, hey, we're ready for the next frame. Okay? So that is the assignment. You just have to read in the config file and put it in there, and I'll talk about that a bit more in the next coding lecture. But now what I'm going to do is talk about the environment setup. Because this is like, I'll always get a couple of questions about this, and what I will tell you is, if for Linux, Windows, and hopefully for Mac, if it didn't work, it's because you did something wrong. Okay? So you're like, oh, the instructions don't work. It's very unlikely. Like hundreds of people have used these instructions and they've worked. I hope they do work, but if I get 60 emails tonight, I'll know that it doesn't work. If I get 2 emails, I know that it worked. If everybody, okay. So SFML 2.5.1 is what I recommend. So if you go to the SFML website, if you copy and paste this, let's see. Okay, so copy and paste that to get SFML 2.5.1. In the last like 2 friggin' weeks, SFML came out with a new version. And I couldn't update the assignment in time to make sure that it works. So you can try the new version if you want, but if you see 2.5.1 referred to in the notes, it's because 2.5.1 has been out for 5.5 years. And so they just went from 2.5.1 to 2.6. So possibly for assignment 2, I'll be switching to 2.6, in which case you would just have to download that and change an environment variable. But let's just work with 2.5.1 for now, because I know that it works. So if you download 2.6 and it doesn't work with IMGUI or whatever, sorry, just go to the URL that I had there, or older versions, 2.5.1. And then over here, this is the version that I want you to download. So the Visual Studio project file is set up 64-bit. So you download this zip file. That is the zip file that you download if you're in Windows. Okay, let's go back. There are some simple tutorials here for SFML, and I will be going through those in the next lecture. Linux instructions. Note, do not type this character. I just start the line with that character to show you that it's a terminal command. Okay? So that's just make sure, because I'll get people saying, hey, I typed this and it told me it wasn't a valid character or whatever. So in Linux, the very first thing that you have to do is install GCC, make, and SFML on your system. Make is the thing that uses the makefile, and so you need that. In Ubuntu, similar command to apt-get install. You're just saying sudo apt-get install g++ build-essential is what installs make, and lib-sfml-dev installs SFML. You're done. Yay, Linux. It's really good for some things. Then you download and extract the assignment zip file. So you can type unzip, the name of the zip file, -d will create a new directory, or if a directory exists, it'll extract it to that directory. So then extract the archive into a folder named whatever. Then you navigate to the assignment root directory. By that, I mean in the terminal. Then you can compile the entire program by typing one single line of code. But don't do that. We're going to use the makefile. Or by using the included makefile by typing make. This will place the executable called SFML game inside the bin folder, change directory into the bin folder, and then run the game by typing /SFML game. But doing all that is a bit cumbersome, and you can just type make run. Make run will compile, change directory, and run your program in a single command. Now, if this works, I'm logged into my... come on, dude. I'm going to try this once. I've got my home VM. Go away. This is my... Has anyone used Proxmox before? It's really cool. It's like a server, but for VMs. So this is my home server. All right. So this is just a blank Linux VM that I have. Perfect. All right. So it works. So this is on Linux. This is what it's going to look like on Mac as well if you end up using the terminal. So here I've got the A1 marks file, the bin directory, the make file, the readme.txt, the source, and the Visual Studio file. So if I type make, it was already made. So this will just relink it. So it has, okay, what is this command? Well, that's what it just linked. So if I want to redo the making, I can type make clean. Make clean will remove all of the object files and the binary file that I've created. So now it's as if I had just extracted the assignment. Oh, of course, it doesn't change your code. It just deletes the intermediary files. If I type make, it will start compiling. So it will compile each CPP file, including IMGUI. So it does have to compile IMGUI. But if all you're doing is changing your main file, then the next time I type make, I will not recompile IMGUI. It will just be the main file that's being compiled. So now what this has done is it has produced the output file, so I can cd into bin, and then type /SFML game, and then run it. And here we go. I have the assignment running in Linux. Okay? So Linux is by far the easiest way to get this up and running. It's not super difficult to get up running in Mac either. Windows is the most annoying. So let's go and do this once more. So let's clear the screen. Now make clean. So I delete everything that I just did. And now if I just type make run, it will compile and run it. So the makefile does all of this for you as long as you have make installed. There you go. So it makes it and runs it. Okay, and last thing I'll show you is what the makefile actually does. So if we look at the makefile here, all right. So to build the assignment, cd into the assignment directory and then type make. And so the makefile, who's ever used a makefile before? Anyone? Okay, so it just basically sets up all the settings for your compiler. So this, it tells it what the C++ compiler executable is. That is G++, so that's a GNU C++ compiler. The output, that is the name of the executable that will be run. Here, this SFML dir, if you need to manually specify your SFML dir, do so here. That will actually have to be done for Mac M1 and M2 chips, probably, but I'll show you that in the instructions. The compiler and linker flags, so for example, we want to optimize our code, so we do -03. We want the standard of C++ to be C++ 20, and there's an annoying warning of an unused result that's within the IMGUI code, so I've just turned off that warning because you don't want to see that every time you compile your code. Then here are the include folders. So this says, hey, all the code that I'm importing, where is it going to live? So it lives in the source folder and the source/imgui folder, as well as if you need to specify an SFML directory for whatever reason, if your system can't find it on its own, it's in the SFML directory /include. And the LD flags, those are the linker flags. And so the linker flags are link all of the SFML libraries, link OpenGL, as well as link the SFML dir /lib folder. Now, on a Mac, you're going to have to change that, but I didn't realize this is an old version of the makefile. There's another comment in the one that's in your actual assignment directory that has like a commented out line for Mac users that you can basically just uncomment and you'll be fine. Then it says, here are all the source files that you need to compile. Here are the object files that you're going to produce. And then there are a bunch of different targets down here. And so it says, for example, if I type make clean, it's going to run this command, which rm-fs all of the object files and the executable, and make run will make it all, and then if it's successful, it will cd into bin and run the game, and when the game is finished running, it will cd back out of the game folder. Okay, so that's, makefiles can also be used in this janky way of running scripts as well. Okay, so that is in Linux, and also for the Mac, if you end up using Xcode for Mac, good luck. I'm not setting that up for you, but it can be done, and people have done it. All right, so let's get back into the setup. So that is the entire Linux setup. It's actually the easiest of all the setups. Okay, Mac instructions. First, you're going to need, now I have only tested this, no, I have tested on an older Mac OS X that's not M1 or M2, but I tested this one on an M1 Air laptop like 2 days ago. So at the terminal, xcode-select-install, that will install Git and a whole bunch of other things that are necessary to install brew. And I think it installs brew for you, or you may need to go online and type Mac OS X install brew, and there's just like a one-liner that you install brew. Brew is the way of installing the libraries on a Mac. So you type brew install SFML, that will install SFML for you. Then you need to change your makefile, because for some reason, the Mac doesn't know where SFML was installed, even though you told it to. So you type brew info SFML, and then it will tell you where SFML was installed. And so for me, that was opt homebrew seller SFML 2.5.1_1. And then copy that to the makefile so that SFML dir now reads that line. And then it should work. And then there's one other thing you have to do, is that instead in the makefile for Linux, you can type -lgl, and that links OpenGL for you. In the Mac, you need to say -framework OpenGL instead of -lgl, because it's a Mac. And that's only necessary if you want to use IMGUI, but we are using it for these assignments. So, and then you follow the Linux instructions. Okay? Yeah.
You know how previously when you were running the assignments, you were running an exe file?
Yeah.
When we do it on the Mac, it's probably going to be the file relevant to that.
It's just going to be called SFML, and then you run it from the terminal, just like in Linux. So it's literally the exact same as Linux beyond the setup of the makefile. And so what I would recommend if you're using a Mac in order to get it set up the easiest possible, do this, and then just edit your source code with VS Code. And so you edit the source code, you click save, and then you go back, you type make, or you open the terminal that's below, you go terminal, new terminal in VS Code, you have a terminal right there, you can do everything within VS Code. You can install all the extensions you want for C++ and autocomplete. VS Code will work on a Mac, but whatever you do, do not install Visual Studio for Mac. It is not what you think it is. It is another IDE that Microsoft bought and called Visual Studio for Mac, but it's not Visual Studio for Mac. It's Visual Studio for Mac. Don't install Visual Studio for Mac. You can use VS Code, you can use Notepad, you can use Vim. I don't care how you edit the source code files, but I would recommend doing it this way. If you want to go set up Xcode, you're on your own. If you want to write a tutorial for it, I'll add it here, but I am providing nothing for you. Except SFML does have a bit of a thing where it tries to set it up, but with IMGUI, I wouldn't recommend it. Mac resolutions are insane for some reason, so your window might be really small. So just edit the configuration file. All right, Windows instructions. This is where, friggin' Windows. Okay. So Windows is the hardest to set up, but will have the easiest time programming. It's a trade-off. There's always trade-offs. So download and install Microsoft Visual Studio 2022 Community Edition. It's free. You just have to sign in using a Microsoft account. That's it. Ensure that when you install it, desktop development with C++ is selected during the install. That's the only additional thing you have to click. You can install the whole thing and take up 100 gigs of space if you want to, but desktop development with C++ has to be installed or it won't work. And note that this is not Visual Studio Code, it is not VS Code, it is Microsoft Visual Studio 2022 Community Edition. Visual Studio and VS Code are not the same thing. I'll still get 5 emails about it. All right. Download the latest 64-bit version of SFML. I said the latest, but just copy and paste that. It'll be so much easier. I've given you the link to the zip file. Don't use 2.6. I haven't tested it. Or use it and tell me if it worked. Extract SFML to a folder on your computer with no spaces in it. I recommend creating a folder called like C libraries. I personally have a folder on the C drive called dev, so it's C dev. In there, I have libraries, C dev libraries, and then you'll get something like C libraries SFML-2.5.1. The reason I say no spaces is because sometimes Visual Studio in the past with environment variables, which we'll talk about in a second, doesn't like things with spaces in them. So I'm sorry, that is Windows, it's not me. Next, so this is where SFML lives on your system. You've just put it somewhere. Windows is not like a development operating system, so it hasn't put it somewhere nice that it knows about. You have to tell Visual Studio where this is. So inside Visual Studio, the way I've done this, to try and make it as easy as possible, inside the project file, properties, VCC plus directories, oh yeah, that's a great font size. So up here, include directories, I said it's inside the SFML directory /include. And library directories, those are the libs, inside the SFML directory /lib. So all we have to do now is set up this variable. If you ever see $, and then in parentheses a variable name, that refers to an environment variable within Windows that you have set up. So after you have installed Visual Studio, don't run it yet, because it reads the environment variables when it starts. Okay, so we're going to click, we're going to click the Start menu and create a Windows environment variable used by Visual Studio to point to the SFML include directory. So the way you do that, you click the Start menu, you type env, and then Edit Environment Variables for your account is going to show up. You're going to click that. Then you're going to click New and Create. You're going to call it SFML-dir, and you're going to give it the variable of wherever you installed SFML. So if I do that here, I type env. Now, edit the system environment variables. It looks a little bit different on Windows 10. Click that. Now I click environment variables down here. Then up here, I create new. I give it a variable name of SFML underscore dir in all caps and a variable, and what you should have in the end is something that looks like that. So this tells your system that's where SFML dir, that's where the SFML is. And the next thing we're going to be doing, as I'll just show you here while I have this open, is that there are some DLL files, dynamically linked libraries, that Windows needs to know where they are and actually to be able to run your executable at runtime. And so what we're going to do is we're going to create a new folder on your path, which is the link to the bin directory. So I think what it says is to do this, where it's SFML, FML dir /bin. So you can do that. Whenever I set this up, I just hard-coded it. Whatever, as long as it's there so it knows where the DLL files are. Okay. That will probably not work if the environment variable has spaces in it. If you had Visual Studio open, you now need to restart it, or actually keep it closed. Oh, because I didn't include this story. Okay. Download the assignment zip file from the link sent to you via email. Navigate to the Visual Studio folder inside that folder. Double-click sfmlgame.sln, the VS solution file. Visual Studio should launch. Click OK to any warnings that may show up. You shouldn't get any warnings, but just if there are warnings, click OK. It'll be OK. Now you need to tell Windows where the DLL files are by adding them to the path. So this is how you do that. And this reads the environment variable of SFML dir /bin. Okay, so that'll do that for you. Then click OK. You may need to restart Visual Studio after this step if it says DLL not found when it tries to run your program. So if you try and double-click, so if it compiles successfully, but then when you go to run it, it says DLL not found, then you need to do that properly or restart Visual Studio. Then inside Visual Studio, here, by default, this will be set to debug. So there are different building options. One is debug, one is release. Debug is used to debug the program. It runs hundreds of times slower. So if you get to assignment 2 or 3 and you're like, Dave, my game is only running at like 10 frames per second, it's probably because you have debug selected. You can run it in debug mode if you want to. You can set breakpoints. You can do all sorts of stuff. I might get into that later. But select release mode. And then what you can do is you can either right-click and click build. Okay, and now I should show this here. Okay, right-click. I'm going to click rebuild. Rebuild will make clean, essentially, and then type make again. So down here, it is compiling all of our stuff. Okay, there's a couple of warnings of conversions from floats. I didn't fix that. But they're just warnings. It's fine. And down here, it'll say 1 succeeded, 0 failed, 0 skipped. What does that mean? It means we tried to compile all of these projects, of which there are 1, and 1 of them succeeded. If you get any compilation errors in Visual Studio, scroll. If this says 1 failed, then you scroll up and you look at the output here. And that's where your error message will be in that window. Okay? All right. Or you can just click this button, which will compile and run your code in one click. That button, if you have compilation errors when you click that button, it says, would you like to run the last successful build? I had a student click yes to that and then clicked always and didn't know. They were like, why isn't my code changing? And so what they had done, and I'm not like, I know it's funny, but like it's a real thing that can happen. Never ever run the last successful build. Because what it does is if there are errors, it just doesn't, like it shows you them, but it just runs the last thing. And they were just like, they couldn't figure out what was going wrong. And that was the problem. So don't do that. Then we come back over. If everything was successful, no errors should pop up. To compile and run in one click, click Local Windows Debugger at the top of VS. Some common Windows errors. If it says in the compilation output, SFML/graphics was not found, then you didn't do step 4 correctly, which is setting up or extracting SFML into a directory and then setting up the SFML dir and then restarting Visual Studio if you haven't yet. So that'll say graphics not found. That means it can't find the library when you go to compile. And if it says DLL not found, then you didn't do step 9 correctly, which is setting up so that the DLLs are in your Windows path directory. So again, what the path directory is whenever you try and run anything from the console in Visual Studio, it will see if it exists. If it exists in the current directory, it will use those. But if it doesn't find them in the current directory, then it will look it up in any of the directories listed in your path directory, and that's where it's going to find the DLL files. All right, so that's it for assignment 1. Remember that in the next lecture, bring your laptops if you want to work on the assignment. I'll be here the whole lecture. I'm not sure if I'm going to be lecturing the whole lecture, but I'd be happy. Go try and set this up. If you have problems setting it up, you did it wrong. But if you really don't believe me, bring it in, and then I'll try and help you with it, okay? And if you set it up today, then you can come to my office hours from 4 to 5 if you have any questions. The assignment link is not active yet because I've renamed it something hidden, but I'm going to go back to my office and rename that file, and so within an hour, you should have, that should be, so let's just say by 5 p.m., to be sure, your assignment 1 download link will be active, and you'll be able to download that, okay? All right, if you set this up, please, before I get 30 DMs on Discord, trust me that this works. If you have a Mac, please try and set it up early, and if any of this didn't work, I need to know so I can update the Mac instructions, because I don't own a Mac. I had to go to someone to get their Mac and set this up, and it worked on their laptop, but I can't test it in multiple different ways. So, all right, that's it. Thanks.